Hello guys, let's get right into it. The first thing you have to know is that machine learning is 99% of artificial intelligence. The backbone of AI used to find patterns in data. So there are two major types. Traditional machine learning, which works with structured data. This structured data is 90% of the machine learning jobs. And secondly, there is deep learning, which works with unstructured data, the fun stuff like natural language processing, computer vision, large language models, 10% of the machine learning jobs out there. Let's get into traditional machine learning. So is the workhorse of AI. Classification and regression are literally 90% of the work. Also, there is the gradient boosting, XGBoost, which dominates. Deep learning will rarely beat it for structured data. And in traditional ML, 80% of the job is data cleaning, 20% is modeling. Model building is more or less a solved problem, but data processing, now that's where the real challenge is. Let's go to deep learning, which has very niche jobs. So there is NLP, the large language models like GPT, retrieval augmented generation, and computer vision, whereby you have your convoluted neural networks, layout LMV3, your transformers. There's a harsh truth that I came to find out, especially being a fourth-year student in campus, being that there are literally no entry-level machine learning jobs. 99% are just very experienced people who learn these jobs. Most companies won't hand over their machine learning systems to fresh graduates. This led me to uncover a realistic path to machine learning engineering, which is what I want to pursue. So first is you can start as a data analyst, whereby you can work for 2 to 3 years. Here you have to learn SQL, the visualization and business impact, understanding how you can merge tools, for example, Tableau, Power BI, into your jobs and at least get real world experience with SQL. And then you move to data engineering for another maybe 2 to 3 years, whereby now you have to build the machine learning pipelines and work with cloud and big data. So the snowflakes, the data warehouses, BigQuery, you also have to learn the cloud, Azure and all that for you now to transition to machine learning engineering. Here you have experience with the data, with the cloud and with scalable systems. So now let's get into the skills you'll need for machine learning. So number one, it's SQL. This is basically the heart of data jobs. I don't know if it's SQL or SQL, however you like to pronounce it. I say SQL, but that's the heart of all data jobs. Data analytics, data analysis, data engineering, machine learning engineering. You have to know SQL. Almost all the data is stored in relational databases, the PostgreSQL, MySQL, use of SQL Server. And to get a data analyst role, it's very crucial for you to have at least one SQL certification. And one that I have seen that I'll do after I finish some other stuff is the Oracle SQL certification. Looks to come in really handy when you're maybe applying for jobs and all that. Secondly, you need to know statistics and data cleansing. Machine learning is all about the data. The models too, but as we said, each percent of machine learning involves data cleansing. So you have to understand the data. Subjects such as outliers, imputation, and statistical principles for real-world data sets. Third thing, Python. It's basically the ML language. It's readable, interpreted, dynamically typed. It has all essential machine learning libraries, scikit-learn, pandas, numpy, matplotlib. You have to understand all that, yeah? Then we go to feature engineering. So here you have to understand how to create features, the transformation, selection, and extraction in order to improve the model accuracy. Fifth, cloud technology, because this is where the machine learning algorithms run. For example, Azure, Amazon Web Services, and Google Cloud Platform. They provide scalable computing power for ML models. So ML requires the cloud skills to process the large data sets and to deploy the models. Next, you at least have to understand some deep learning knowledge. You said it's 10% of the job, but you still need to understand it. In computer vision, you have to understand TensorFlow, PyTorch, or Keras. Next, in natural language processing, you have to understand the transformers, LoRa, retrieval augmented generation. Finally, you have to read the machine learning papers. It helps you master everything that you've been studying so far, and then you can actually see how people have applied this into the real world. For example, number one, Attention is All You Need, which introduced transformers and the basis of the GPTs. Number 2, an image is worth 16 by 16 words, which helps in vision transformers. And then LoRa, which shows us how to fine-tune LLMs without massive compute power. Basically, all I'm trying to say is that machine learning engineering is hard but possible. Companies don't pay over 250 grand for something you can learn in a year. It isn't about shortcuts, it's about deep understanding, practical experience, and solving real-world problems. Focus on building projects, mastering data, and understanding cloud infrastructure. And more importantly, getting real-world experience and also the certification, not certificates for completion. See you in the next video.